Hey, what's up, guys? This is Cheng here. So this LeetCode number 2013, detect squares. Okay. So this one, okay. So now we have a two XY plane, right? And then we have a class, right? We need to design here. So we need to implement two functions, right? So the first one is add. Basically, we'll be adding this point into this XY plane, right? And then we have a count. So the add and also the duplicate points are allowed. So which means at the same location coordinates, we could have multiple points, right? And then the second one is a count, right? Where for the count, you're given like a point, right? And then you need to find the other 3 points that can form a square, right? So for example, right, let's say given like a point, right? So given like, let's say given this point, this is a point that we are passing into this count here. So we can have like multiple possible squares, right? So for example, this one, so like it's a 1, right? And this one is also a 1. Sorry, square, right? Like this. So this is a square, right? And this is also a square, right? And it just asks you to find the count, how many possible squares we can make, right? So for example, we have this one, right? There are a bunch of them, and yeah, they're like the answer is so in the end we'll have like 2 squares. Okay, yeah, so that's it, right? I mean, just like implementation, right? So one thing to be noticed that since we have a count, so let's say given like this point, right? Let's say there's a 1 here, there's a 1 point here, 1 point here, right? Let's say there are 2 at this little coordinates. We have 2 points here. Then what's gonna be the total number? It's gonna be a 2, right? So basically, it's gonna be the multiplication for all the other 3 points, right? If we have 2 points here, 3 points here, and 2 points here, so what are the total squares we can make, right? Given like this point, it's gonna be 2 times 3 times 2, right? Which is 12, right? And the last thing is that if we have another point here, right? Basically, we need to ignore this one. So let's say if this one has like 3 points here, if you're given like a point here, it doesn't really matter because we cannot use the point here. It has to be the points other than the given point, right? And yeah, I think that's it. So in order to do that, we're gonna have like a dictionary, right? We can either do it per line or per horizontal line or per vertical line here, right? Either way is fine. We need to basically store like make a dictionary of a dictionary, right? To store like a link because given like an x, right? So let's say given like xy here, right? So this point has xy. We have x here, and then if we need a dictionary to can tell us all the possible not all the other points on the same y, right? So if we have another point here, right, by given this y here, right? Sorry, not x. Okay, by given this y here, we can easily get all the possible points, right, on the same line here, and then we can just loop through everything, right? Because given like 2 points, we have a side, right? We have side here, and then we have once we have this side, uh, it's easy for us to find the other 2 possible corner, right? Let's say we have this two node, right? 2 points fixed. So what could be the possible squares? So there are only 2 possible squares, right? One is above them, the other one is like below it, right? If we already have fixed this one. Okay. So I think that's it, right? I mean, actually, so for this one, I spent I misread this word squares. For some reason I thought this one is a rectangle. I didn't realize for some reason I didn't realize this is like it's a squares. I thought it's a rectangles. So for the rectangles, it'll be more complicated because if it is a rectangle, right? Let's say given like these 2 points, right? We have a side, right? But then we don't know which the other side could be at here, could be here, right? It could be here, right? So which means we cannot fix the other side. So which means we have to loop through all the other side. So if we want to do it, if this one it asks you to detect the rectangles, it'll be more difficult because in that case, besides this points dictionary, we also need like dictionary to store all the lines, right? So basically, we need to store the key will be the lines, the starting point and ending point for the line, right? And then we're gonna store the count for that, which means at each of the given like a side here, we're gonna loop through all the other side, all the other lines, right? Who has the same key, right? Who has the same start and end, and then we're gonna accumulate all those lines together. But since this one is a squares, we don't have to do that. So this one is much easier, right? And yeah, so let's do it, right? So the implementation is pretty easy actually. Once you realize it's a squares, not like rectangles. So we have points per y, right? Default dictionary of So here we use a Python trick here. So it's a dictionary of a dictionary. It's a dictionary as a counter, okay? And then here we have x and y, right? And then here we simply just increase the counter for this for the same points per y, right? We have y and x, okay, increased by 1, right? Yeah, basically given this y and we have this x, we increase the point by 1. And then here we do a x1 and y's point, right? Because we will need this y to find all the other x. So so here we have points, right? So given this y, we can find all the points on the same y axis, right? It's going to be a self dot points per y, right? Dot this one. Okay, the answer will be 0. And for x2 in points dot keys, right? So because it's a counter, but keep in mind that we need to exclude this case, right? Because this point itself, right? So this x itself may also be part of this points dictionary here, but we cannot use the same x because we need like a line has actual length, right? If the x1 y x1 and x2 are the same, then there is just a point, right? There's no line there because we need like with a positive area, right? Here we do so the first point is always this, right? We have y and x2. Okay. Basically, let's say we have so this is the point, right? So this is a x1 and y, right? So here the x2 is like this, right? So this is x2, okay? x2y, right? So with this 2, we need to find the other 2 points, right? So one, like I said, one way is like this, right? The other one way is this. The other way is here, right? Then what's this, right? So how about these 2 lines, these 2 points? Basically, we need to find. Sorry, this is going to be a multiplication, right? Self dot points per y. It's going to be a y plus, right? So how long is the side, right? It's an ABS of x1 minus x2, right? And then x1, right? So this one is this, right? So this, right? Similarly for the other one, right? We need to find this one. I can just copy and paste, right? Because they are on the same x. It's going to be x2, right? So basically this one is this one, right? Similarly for the for another possible squares, right, I can just copy and paste here. The only difference for this one is that it will go down, right? So that's why the y-axis will be subtract this side. Okay, same thing for this one, right? And then return the answer in the end. Yeah, I think that's it, right? Run it, submit. Yeah, so it works, right? Because the time complexity is 5,000, right? 5,000 calls for this, and here we have what? It's gonna be 5. I think it's close to n square, I would say, right? For each of the call here, we have for loop here, right? So close to n square time complexity. Yeah, I think for this one, nothing too fancy, right? Because since this one is only to ask us to detect the squares instead of rectangles, that's why all we need is this one nested dictionary, right? And then yeah, cool. I think I'll just stop here. And thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.